Alright, making a video. Looks like it anyway. Probably use some camera adjustment. Anyway, close enough. I have to find a better location, but just haven't gotten around to it. Sorry. So anyway, I guess I'll start with some comments and then get to some two-slit stuff with whatever his name is, Robert something Ritchie. Well anyway, wait till then. Just statements about stuff. Yeah, I'll see where my subjects go. Open conversation, sort of. So this first guy, Alexander Livingston, these people are just so brilliant. I made it 2 minutes into your video, and you're already wrong. Whoa, because Alexander says so. All electricity is AC current. Well, no, it really isn't. So it's a stupid statement. And I don't think I ever stated anything inaccurate about the fact that, yes, AC current is what they use to transmit electricity over distance because voltage is easier to move than current. But anyway, but that's because of Tesla in capital letters. Now, Tesla did not invent AC current. He didn't invent AC current over transmission lines. He didn't do any of that, okay? He did modifications to a motor, and that's what he did. Especially the three-phase idea of brushless motors. That's Tesla's contribution. This aggrandized crapola that Tesla provided us with the ability to understand electricity, and if it wasn't for Tesla we wouldn't understand electricity, is just absolute nonsense. He had made a tiny contribution compared to all the other people we know of. Tiny. Anyway. At that point, all you knew was DC current. So again, just they obviously didn't. That wasn't obviously all they knew, because Edison's generators basically created a type of alternating current in the sense it was on and off, which is a kind of alternating current. But anyway, just a useless tripe. But so I've been reading now and then. I go to the Tesla.com site or whatever it's called. And they have a lot of newspaper articles from the time and that kind of stuff, and they're all kind of fluff pieces, but you do get a glimpse. Apparently, he was a bit of a wino. When he was for abolishing prohibition, because I guess he liked to drink wine. But anyway, in the context of things, I don't know. It's for a scientist to think that alcohol is serving mankind. He called it a stimulant. What it did is stimulated a lot of ruined families and dead people on the road. It's a hugely expensive vice. But anyway, so I didn't think it was very logical there as a scientist. And then there's you get a glimpse into some of these theories he had, and his basic notion is that he could send electricity. He thought most of the electricity went through the ground, and so he had some kind of idea, like he could have free electricity in the air because all the electricity was kind of going through the ground or something, which demonstrates absolutely no understanding of how ground works, or understanding of alternating current in the sense of positive and negative, and it's only positive and negative relative to ground. In a sense, you're just that's all you've really got is without the middle ground, you kind of have just on and off. The ground is what allows you to apply a negative number, and the ground is a huge sink. It's a gigantic, dense thing made of all the mass of the earth is the ground. So to think that you could somehow put a charge potential on the entire mass of the earth and transmit that potential to another location, like somehow magically you could add some more voltage here and the ground would allow you to access it someplace else as by some sort of magic, is insipid. The ground is a sink. It doesn't allow you to keep it to unbalance it. It absorbs any imbalance instantaneously. That's all it does, is suck up imbalance. That's its only function. So Tesla was a dope in that sense. He had it completely wrong, and that's why none of his imagined crapola will ever come to fruition. You will never send high voltages or high amperages or high wattages through the atmosphere. It's not going to happen. You can barely do it through conductors. Alright, anyway. So then Tony S. Couldn't stand to watch 5 minutes total of your video to see if you eventually got to... So you couldn't stand it, but you were eventually waiting for something? Explain the illusion. Your attitude sucks. So it's a ferrocell video. I don't know which one it was, but clearly I have, explained the phenomenon. That there's no mystery to it. It's just you're getting a distorted view of reality from a bunch of mirrors, essentially created by the ferro material, and those mirrors have angles, and those angles add up to a perception you get, but the perception has nothing to do with where the little filings are themselves lined up. Your image sucks. Is that you when you were a baby, ugly baby, or is that your ugly baby? Yeah, so fuck you, asshole. People. I mean, it's probably best I don't get comments, just because they are so fucking stupid. Clearly nobody who can make coherent arguments about physics can find this channel, apparently, at this point. So they're too busy arguing, I guess, with flat earthers or something. Whatever. It's dismal. So off to the two-slit thing, or I guess I'll do a little rag on the D. Hilster videos are just so useless. It's just a waste of time to watch. I mean, there's no real physics argued. It's all citations to this or to this book or this book or this or there's some other kind of crap, and no way to understand whether the crap is worth bothering with. Scientific League guy thinks he's doing God's work and moving broccoli with a magnet. Again, just more paramagnetic kind of stuff, and not at all miraculous. So then we do have the Robert Ritchie. I'll play some of that. What we haven't gotten yet is a Pyrrho reaction to the D. Hilster expanding Earth theory. So I'm waiting on that one. You should have some reaction, I would imagine, to that horse shit, being spouted. I mean, it's just nothing but another flat Earth theory, because of a couple of the observations you might have as an Earthling. You might draw the conclusion the Earth is flat. Some of the evidence indicates so. But it's a tiny fraction of the evidence, and the vast majority of the evidence doesn't indicate that at all. And the vast majority of the evidence indicates that the oil in the ground is basically a bunch of carbon, like coal, that got circummed by moving continental masses that folded over it and crushed it into oil. That kind of shit happened. The Earth doesn't make oil, and it certainly doesn't make water. So there's no theory for any of that crap, and it certainly doesn't make Earth. Well, anyway, you can just go through all the, like I said, all the stuff that just makes this theory impossible to be true. The phase of the moon has been consistent for hundreds of millions of years. And that's built into our biology, hardwired, so hardwired that women essentially still have a cycle, that has the moon phase built into it. This is just retarded nonsense to be arguing that this is some well-established, viable theory of reality. And it just, this just makes us, like I said, it makes dissidents look like crackpots when they spout this crap as if they're talking something other than just complete shit. So anyway, that was some other stupid thing, and I'm just not seeing it here. I guess I have to go back further. But oh yeah, the Newton versus Aristotle argument on the Saturday chat. I don't know why they post these videos so late. Should be able to post them the same day. But anyway, so they spend an hour and a half arguing between the notion that yes, we observe that everything, the Aristotle thing, where everything in motion appears to want to not be in motion. It wants to just stand still. That's because everything in motion in this environment is bombarded by other forces constantly, and it has to travel through mediums that are full of energy, full of things moving. So yes, of course there's drag. Everywhere around us there's drag, friction, and so Aristotle was right, but right about nothing, because he didn't really understand anything about how the real game works. And then Newton comes along and points out that now everything wants to stay the way it is, whether it's moving or not moving, and and even the want thing is kind of stupid, because it really doesn't want to do anything, and it's just doing what it's already been told to do. So if the Earth blows up and we fly into space, it blows up in not too harsh a way, and we don't all burn up to a cinder, we just kind of get flung into space. Well, we got a bunch of energy put into us, a bunch of acceleration, a bunch of little bits of shit banged into us and pushed us. And yeah, we'll keep moving until some other little bits from somewhere else tells us we don't have to move anymore. And they'll take away that energy and replace it with a new momentum, rebalance us. But that's all we are. So we're in a state like the ground of the Earth. We're in an electrical state, and that state can be changed by something adding or subtracting from it in terms of a direction. Momentum is just a byproduct of having your disposition changed from blue to red, or from forward to backward. And it's something you possess. It's something that happens to you. So when you're moving, you have that movement inside of you. It's a force. It's an actual thing. It'd be nice if we could see velocity as a color, or as some other way that there'd be an indication of our velocity. But it's always part of you. The Earth's rotation is part of you right now. The movement of the Earth around the sun is part of you. The sun in the galaxy is part of you. All of those things are part of your motion, and you're actually flying in a vector. That is the addition of all of those. Every second you move a certain way based on the combination of all those movements, and that every second that movement changes based on the addition of all those momentums. I would say that's the obvious answer. So both were, Aristotle's correct that on Earth, in an environment where you're bombarded with neutralizing energies, you're going to get dragged to a halt. And in an environment where you're not getting affected by a bunch of stuff hitting you in an uneven way, you're not going to get slowed down. That makes sense. So anyway, so yeah, just surprising they spent an hour and a half on a subject that, I think the answer is kind of obvious, that you move because you're accelerated, and when you're accelerated, you're filled with force in a direction, and until something else rebalances that force inside of you, you're going to be stuck with that bias. So anyway, so what else? I don't think there's anything else there. So I guess I'll just go on a short little statement. I'll make a video pointing it out. I have made previous videos, lots of them, obviously. I think the universe is really simple. It just requires you to have two forces, plus, minus, red, black, however you want to think of them, little bits. And then you have two bigger bits called a proton and an electron, and they have the same bias, red and black. And the trick is that if the black hits the black, it reflects. If the red hits the red, it reflects. And if the black hits the red, it is released perpendicularly. It goes off the side of the boat, so to speak. And likewise, if the black hits the red, it goes out the side. And through that simple mechanism, you can explain the most important thing, I think, which is magnetism, really well. And the little bits all move the speed of light, which means they can account for magnetism, which is really just gravity being filtered by a magnet, so they can understand where the force for magnetism comes from. It's the same force that creates gravity. Gravity is explained, and charge and electricity is all explained. So what's left? Photons. Photons are just the little bits out of frequency, so you're just changing how close they are to each other. And the difference in their impact on an electron just has to do with the electrons in a state, okay, of tension. And if you want to knock it out of its tension, you have to hit it based on its resonance, the frequency it can vibrate at. So if you don't hit it at the right frequency, so if I hit something, give it momentum, and then I let it come back again, and then hit it again, well, I've lost that much energy. I've just defeated it. Whereas if I hit it, and then it moves, and then I hit it again before it can spring back, it goes deeper. If I hit it again, it goes deeper. So if I hit it at the right frequency, I can cause a huge amount of motion. And if I hit the wrong frequency, I basically don't annihilate the energy, but I convert the energy into energy going the wrong way. It's not going to affect the thing I'm trying to affect. I won't load the spring. I won't be adding energy to the tension between the electrons if I hit at the wrong vibrational speed. And that explains the whole photoelectric effect, and why electrons notice what frequency they're getting hit by, and why different atoms react differently to different frequencies. So anyway, it's all that simple. So the universe really is that simple. You don't need anything called the force fields. I mean, I like the word field to describe when you have the force has a huge bias in it. You can see the bias, but the energy's all around us all the time, and all you're really doing is changing blue soldiers into red soldiers, and the different kinds of soldiers rape and pillage in a different way. And that creates all the complexity that we see, is that little bit of difference. But you don't need anything else. You don't need quarks, you don't need muons, gluons, muons, you don't need any of this crap. All you need is charged particles, and once you figure out that it's basically electrons and protons are filters, they're basically the magnetic monopoles. They filter the energy. That means they will cause one form of energy to go one way and the other form to go another way. Then you have all you need to explain all the effects you see in terms of repulsion and attraction. With that as a preface, we'll, I guess, move on to this less than complete or even cognizable explanation of the double slit experiment as promised, and it's just yes, not very impressive.
Get what we call a stress tensor field across the slit. Now, you will notice, if any of you people have read up about...
So a stress tensor field created across this... What is that? That doesn't say anything to anybody with a brain. What, a stress tensor field of what? Tied to what? Tied how? What mechanism is bonding to create any tension? What are you talking about? I can understand the fibers on a rope. You know, the little fibers are sticking out of the side of the little rope fibers, and all getting knotted into each other, and they're all... you add them all up there, it's a very strong bond that's created. I can explain the mechanics of that and understand it. There's no mechanics to what you're talking about. It creates a stress tensor field. From what? Out of what? Made of what?
The double slit experiment or the single slit experiment, the larger the particle they use, the smaller the slit has to be relative. The ratio has to be lower between the size of the particle and the size of the slit.
Yeah, there's no rational reasoning provided for why they do it that way, but there's no obligation as far as I know. I mean, obviously you can't make it too much smaller, so I don't think they're throwing buckyballs through a smaller slit than the slit they're using for light, let's say. There'd be no reason to, and obviously you would expect a different result, and maybe that's why their pattern sucks, is because they're doing that. But I don't think there's any rule that says they have to do that. I mean, I could show a clip from let's see, do I have it reasonably available? Where did I put that? That's my video. That's my video. It's some other video, but not what I'm looking for. Maybe it's down here at the end. Somebody had linked to this, you know, one of the snarky commenters. These are really interesting, so I'll put the link to the channel page anyway, I guess. There's a couple of different videos that have these different effects. So this guy's using spaghetti here. There's no sound. And what he basically has is two really big telescope type lenses, you know, this long, basic telephoto lenses, facing each other, and he's somehow shooting a laser beam, and I think it's going back and forth here. So I think what these images are like an infinity thing, you know, where the image goes to infinity when you repeat it a little bit off. So I think that's what's happening here. So it looks like a double slit pattern, but it really isn't. It's an optical illusion. And I remember seeing this years ago, and it was quite impressive, because I said, you know, he does it with a single surface, and you see the fringe pattern around single surfaces. But now that I see this, I'm starting to realize that maybe that's just an optical illusion, and he wasn't really capturing that. Because obviously at this distance, this doesn't work for any theory. I mean, no theory can explain how you'd get a fringe pattern with two items separated by this distance. It just doesn't make any sense any way you look at it. And you can sort of get the idea that this is the real spaghetti, these dark spots, because they don't move. Well, no, they should move though. That would be if they were that. Yeah. So I don't know what's causing them, because they don't move, and they should. As the pattern changes, these, if it was a real two-slit pattern, these dark spots would also move. They wouldn't stay in the same exact location as the pattern gets tighter and weaker. So this is part of the optical effect, this dark area. So anyway, it's just kind of disappointing that it doesn't have any videos explaining what he's actually done, and I think he used to. So it is kind of weird. The videos don't have a lot of views, even though they're, you know, 4 years old now. But they're really quite interesting effects. But again, this is like the Faro cell. It's not doing the truth thing. It's doing something quite different than the truth. So anyway, I don't know exactly why I wanted to throw that in, but I figured I'd throw it in. Just because you know, this is lots of misinformation, lots of distortions, you know, dodges and distractions from the truth.
There's another clue, because you need a higher field density because of the increased size of the particle. But with a photon, it's slightly different. A photon doesn't have any mass. But here's where it changes, because it's going through air, and I'd love to see this experiment done in space. You'd still get the effect, but I don't think it would be as pronounced.
So anyway, yeah, it's a nice thing. Yeah, sure, I'd like to see it done in a vacuum. Obviously, it doesn't even have to be done in space. It could just be done in a vacuum. And I haven't seen it done in a vacuum. The only case would be the case with electrons, when they used an electron gun. That's in a vacuum. But that's with these nanoparticles and gold layers, and it's, you know, that whole experiment's quite suspect. But anyway, but again, this argument about massless particle, mass and momentum, they can't be separated really. If you're going to understand the concept of being able to impose a momentum on something, then you have to say the thing that's imposing it has to have a mass. It's just, I think, fundamentally retarded to think of them as massless when they have momentum. So I'd argue almost the only thing that does have mass is the force, and it's the electron and the proton. They're the things that are sort of massless, except for the force that's inside of them.
We've got the, like I said, it's doing 99.96 or 97% of the speed of light in the medium.
So a useless distinction. So he's sort of arguing that somehow light actually does slow down when it goes through a medium, and I think the obvious argument answer to that is no, the light doesn't slow down. It's just that it's not moving a straight line anymore. Just like a fiber optic cable, the medium requires a longer travel. The longer travel is what causes the slowdown. That makes perfectly good sense. It fits in the sense that that's exactly would mean that it is a percentage of a slowdown. The thicker you make the material, it would be the same percentage. It wouldn't start moving slower and slower and slower. You can see the problem is if you say it moves slower in glass, then you'd have to argue that its percentage would change as you change the thickness, because the light would from the very beginning start to slow down, and the light that would be 1 inch into the glass, now the light's already moving slower, so the rest of the distance you have to say, well, in the next inch it's going to slow down this much more, and the next inch it's going to slow down this much more. You wouldn't be able to say it's a percentage no matter how thick I make the glass. If you can make the glass any amount of thickness, then that indicates that this is about the travel time of the light, not the speed of the light. So it's traveling a longer distance.
There, it's lost 92,000 meters a second of velocity. Now that little tiny leeway that it's got, that alters the characteristics of the photon.
So again, just more nonsense in my opinion. It's clearly the photons aren't altered. They travel through transparent mediums, and there's no indication that, oh, this photon went through a transparent medium and has somehow been changed in any way other than its arrival time changes. So if you shoot light through a piece of glass, it's not like you're going to get different photons. The same photons, you just got them a little later because they had to travel that extra distance. So there's no characteristic of the photon that's fundamentally changed. Of course, polarization could be changed, other things, but that's if you're trying to. You have to change more than just put it through a slow down medium. You have to change the medium
somewhat greatly. And the fact that the air is in the gap as well, that is getting affected by the stress field built between the two sides of the slit. Now, Newton and Young, back in 1801, they would have had no idea this was going on. These fields hadn't even been thought of.
Yeah, and I think they'd be better off not thinking of them because I don't think they're real fields. So I think that's just absolute rubbish. There's no evidence of this electric field or magnetic field. There's no evidence that there's any such thing as a field of anything. There's evidence of something moving the speed of light, which is like light itself. It's not a field of light. They're photons. Jesus.
These guys were the pioneers, and you know, I really take my hat off to them for the experimental work that they did, even with Michael Faraday.
Well, I don't take any hat off. Frankly, for Young, I mean, Newton I'll take my hat off to, but Young was completely unremarkable. Newton had already discovered this phenomenon, and you know, Young was just a wave whore. I mean, he was an audio engineer and wanted to turn sound into waves in a medium. And they're not.
That guy discovered the Faraday rotation, where the polarization of light was actually being rotated through different mediums, and it's used in industry today to check the purity of different crystals. They do a pole test, and you'll see it's say like 99.3 or 99.
Yeah, right. This has so little to do with the double slit experiment, really.
1.4% rotation through crystals of sugar, for example. It gives you the purity of the sugar. And I know this because I worked in a sugar mill, and they got their what they call pole tests, polarization tests. And if you want to see some really advanced chem labs, go to a sugar mill and see what they do there. They're looking at things right down on a molecular scale, and pretty advanced chemistry. But I don't like the chemicals they muck around with. They muck around with the stuff like lead acetate. Oh, I don't want to go near there. They want nothing to do with lead. But anyway, I've got a few notes here. There's is all about the double slit experiment and about photons and just, it's like flat Earth people versus global Earth people, spherical.
Yeah, well, whatever. I don't think it is actually. So I think it's like idiots versus morons. Sorry. I mean, you could just say it. It's wave people against ether people against whatever magical angel people. I mean, you're all talking like somehow you've seen one of these fields, one of these magical fields that make something happen for no mechanical reason.
Oblate spheroid Earth believers. I believe we're living on a globe. I've been to enough places, enough latitudes and longitudes. I tell you what, you notice it up near the equator, it gets dark very quickly. The difference between day and night is very quick, and
He's really not on the subject much.
the sun's directly overhead at certain times of year, anywhere above north of the Tropic of Capricorn, or if you're in the Northern Hemisphere, anywhere south of the Tropic of Cancer. Depending on the time of the year, the sun could be directly overhead at lunchtime. And there's some interesting things to look up, you know, the position of the sun. You go down to the lower latitudes.
Yes, it has nothing to do with the subject, though. Yes, interesting things. Maybe I don't know if those kind of things are all that interesting in a physics conversation, but whatever. Let's get to the point.
Right down the bottom of Australia, and you notice this. The first thing you notice is the sun's way lower. You notice there's a way big difference between night and day. There's a much longer twilight period. Anyway, I'm digressing. I don't want to talk about flat Earth
Yes,
stuff.
thank you.
Where are we? Got lots of notes here. Here we go. Solving photons through a slit or double slit. We're looking at the constants. And so we've got to analyse all the different constants. You've got to look at, so if we're using a red laser around anywhere 650 to 700 nanometers, you're looking at a frequency wave.
Look, all you gotta point out is there's two main variables. Alright, we know the distance to the target is just gives you a distance to the target. The image doesn't change, it just gets bigger or smaller. So you're just magnifying the image or making the image smaller, that's all. Irrelevant to anything important. The only two variables that matter is the width of the opening in the single slit and the frequency of the light. And in the double slit, they use in the math the width of the impediment, and they assume the width of the slit, which doesn't make much sense to me because obviously it's still a variable how wide the opening is. And the four surfaces clearly are still engaged in the experiment, so you know, you're not going to get the double slit pattern without the two outside. These two outside surfaces are critical to getting their true double slit experiment. So these outside ones are likely creating the envelope. But anyway, yeah, so those are the two variables. And as I pointed out, the reason why the frequency would matter is because you are hitting electrons. That's what's causing the diffraction, the bending of the light. It's being caused by the fact that you're hitting an electron with the light. The electron reacts and then it readmits the photon from a different position. And what position it will release the new photon from is going to be dependent on what the frequency of the light was, whether you hit it on its residence or not.
Wavelength, they're related frequency, mate. Let's go just for the frequency. So that's a constant. The slit width will be a constant. The medium, which is air, that'll be a constant. Assuming you've got it in a fixed setup, your distance from the emitter to the slit and your distance from the slit to the receiver plane. And then you've got to take into account relative room temperature.
Yeah, well, you really don't have to account for any of that stuff to get a general picture, a decent enough approximation of what the results are going to be.
So this is what I've got here. You can see I've got a couple of little sketches.
Yeah, totally unremarkable. You know, it's one way of showing it, but what are these lines made out of? Again, this magical field stuff doesn't mean anything. I would argue that the electrons are actually lined up quite differently. They're lined up this way, top to bottom. And we know, look, this is sort of simple logic, just because of the way atoms are structured. The nucleus is the positive stuff, big pile, heavy positive in the center of the atom. The negatives are the electrons around the outside of the atom. And it just seems clear that those electrons, when those orbits are full on the atom, are going to make the atoms not stick to each other. So if they have full valences, whatever the right word is, valence is something like that, they have a full, if they got all the electrons they need, they're just going to bounce off of each other, and they need to have a hole, a missing bit, for them to lock into each other and share an electron. Now, so the basic idea is that you have positive in the center and you have negative on the outside, and it just kind of wreaks that negativeness. And so free electrons, which do exist, so to speak, obviously would be attracted to the proton in the center, just like the other electrons, but repelled by the electrons on the outside. So they're not going to get to the center, they're not going to get anywhere, because they're always hitting against the protecting electrons on the outside. And so any kind of bits of electricity in the form of electrons would be lingering between two slits, two pieces of mass that have protons, are going to be compelling electrons to stay around, hang around. But the electrons on the surface of those atoms are going to tell the electrons buzz off. And so that's the tension that exists. And clearly, as you move two surfaces together, whatever electrons are in there are going to feel more and more pressure. As the two surfaces get closer to closer, the electrons are getting closer and closer to each other, and it's just going to start forcing more of the electrons out. And so you'll have less electrons under more pressure. And that changes how the slit, how much divergence you have in the light. It's being changed by the fact that now they're hitting fewer electrons, but the electrons they're hitting are more pressurized, which causes more divergence in the direction of the photon. So you can sort of see the number of slits as being representative of the number of electrons. So as you reduce the number of electrons, you reduce the number of bars. And at the same time, as you reduce the number of electrons or increase the pressure between the electrons, then you create bigger bars. And there, that's the explanation. I don't know, I'm just saying I think my theory fits the evidence better than your theory. Now I can't, anybody can make up something because we don't have the actual facts. All we can do is try to explain something in simple terms. And what I'm saying is electrons we all know exist. We know if there were free electrons, where would they be between these two surfaces? If there were electrons, if I move the surfaces apart, it's going to change how the electrons are arranged. If I smash the surfaces together, it's going to change how the electrons are going to be arranged. So I say my theory at least has some continuity to what we can understand, where this made up field forcey thing that doesn't say anything about what's it made out of and how does it bend photons.
Which is where I've drawn out the field lines on. That's a top view, looking down from the top into the slit, and that's how the field lines would look. So there's a couple of
Again, field lines, as drawn by Maxwell, are usually illustrating just a place and defining how much pressure there is by drawing the lines at different distances from each other, like a topographical map. So the lines don't have anything to do with the actual force moving along a line. It just has to do with the fact that the force balances, the dipolar magnetic force, would balance across that line as that shape. So it really, it's another illusion. It's a false dodge to look at lines, field lines, and say they're a representation of anything more complicated than the fact that if you were to put a magnet in that location, how does the magnet line up? Does it feel more of this? Does it feel more of that? More southern pressure, more northern pressure? That's all you're seeing, is where would a magnet line up if placed in that location. There's no current or something moving through those field lines.
possibilities there, and the thing is, why it's forming that pattern is it does have a frequency, and yes, it will be arriving at destructive and constructive positions. So if you've got two photons.
So again, I don't think there's any reason to talk about this constructive or destructive interference. There's no evidence that it takes place, really, and there's no theoretical grounding for it. So how exactly do these photons destruct each other? How does that happen? Can you draw me a picture of two photons hitting each other and destructively interfering somehow? Where does their momentum go when they destructively interfere? What happens to their momentum? Where does it go to?
And they're cancelling each other out. You're going to get a dark spot.
Again, cancelling each other out. How does that happen? Did you kill the photon? Did you annihilate it? What happened to the photon? What happened to the momentum? There's no explanation here about any of that. It's not a viable explanation to say there's any such thing as interference in things that aren't a medium. And this is, light is not traveling through a medium. Light knows no medium. It is not controlled by a medium. Light hits electrons. That's what photons do. They hit and affect electrons specifically. They obviously hit other things, but then they're just felt as gravity. It's only the electron that is sensitive to the frequency component. That's it. The electron bound, by an atom. A free electron wouldn't be. It wouldn't care less. It really needs to be an electron bound to have, because that's the tension that the photon is taking advantage of. That's the tension that creates the electron's resident frequency. That's what makes it possible to tip it, so to speak, to put energy and store it in the electron. Is the fact that the electron is in a system that will fight back.
If you've got one photon just landing there and no other photons, then you'll get a medium spot. If you've got two photons landing in phase, then you'll get your brighter spots. So we're looking at...
So this is supposed to be some explanation that debunks the conventional theory, and he just basically just spouted the conventional bullshit. It's just this is completely conventional nonsense. Somehow two photons are stronger. They turn into four photons. I don't know. What's the theory here? And we know it happens to single photons. So again, a single photon goes into the experiment. A single photon hits one of these different locations. So where did you explain how the single photon does that? How it interferes with itself? You didn't deal with the single photon experiment at all.
Different fields around the slit, and it is the slit that causes the problem, and the way we're actually...
Yeah, but why does it cause the problem? Oh, that's right, because it's made out of electrons and protons, and the boundary layer between the matter of the slit material, the opaque matter, the boundary layer between that opaque matter, that thicker matter, or whatever, that non-transmitting matter, and the atmosphere, it's a boundary layer, and boundary layers cause refraction. So clearly photons that go into the boundary layer are going to get refracted. And as you make the slit smaller and smaller and smaller, you increase the size of that boundary layer.
Looking at the experiment,
I mean, obviously the two surfaces start to feel each other's presence as you get smaller and smaller.
If you really want to go right down to the smallest possible level and analyse the path of the photon through the slit.
Yes, that's what I want. I want an explanation that explains in some sort of language or description of how this photon does this. I want to be able to follow the momentum. How does the momentum go in this way, and how does the momentum go out this way or that way or that way?
You'll find there's what they call a tensor of rank 3, and this is manipulating the direction. And one of those...
So that's supposed to mean something to somebody. A tensor of rank 3. So that's your explanation. Bullshit words, Einstein's bullshit tensor crap, that's supposed to mean something. Oh, I'm sorry, it doesn't mean shit to me.
is an electrostatic field due to the close.
Electrostatic field. Again, what the hell is an electrostatic field? It's got to be made out of something. It's got to be made out of electrons under pressure. That's what electricity is. That's what voltage is. You can't have electrostatics without having something that's happening to electrons.
Proximity of the sides of the slit. And this is why we get a more pronounced deflection the closer we move the slit together. Secondly, on top of that electrostatic...
So again, he says this is why. This is why? Because of a tensor? So a tensor makes it happen. Well, that doesn't say anything. Again, that's not a description that can mean something to some regular person. I mean, I'm not saying you have to make it understandable for an imbecile, but just making up the word tensor and saying a tensor in a field, that's it. That's nothing. That doesn't say anything. That's just rubbish. It's just, you might as well say bent space did it.
Static field, we have an infrared field coming from the materials.
Well, infrared field, again, it's just they're either photons or they're not. So yes, there's infrared heat radiation when it finally gets out of an object is in the form of at a frequency, because those are the electrons on the surface likely creating that frequency. But the tension inside of the object doesn't necessarily have to be full of any kind of photons that are actually in the form of infrared. Infrared just happens to be the way the energy is released in clumps of infrared radiation. The energy is in the pressure. The energy is in how close the electrons are to each other and how much energy is bouncing between them. Again, the photons are real things. They have real reflections. They can really be trapped. This is a key concept. Energy is trapped by matter. It's trapped. That's how we can store it in a battery. It's trapped in there as little bits, not getting out, stuck, bouncing back and forth until you take it out. You let it loose. You knock down the ping pong paddle and let the stuff fly.
And this is caused because they're not at absolute zero. They're not even super cooled. All the experiments I've seen have been done at room temperature, and at room temperature on a...
So again, the electron experiments using an electron microscope apparatus is pretty cold in there.
Atomic level, your material is really quite active. The third component of this tensor field is the localized field of the photon. Now normally a photon...
So localized field of a photon, what does that mean? You got a photon that's radiating something. What? It's connected with strings. I mean, what? What is this photon doing? There's absolutely no experiments on Earth that indicate you can fly a photon by, say, anything. Just slide the photon by and somehow it'll jiggle something or do something to something. The only evidence that exists is photons have to hit something. Their energy has to be absorbed, causing movement, and then the photon is either released in either the direction it came from, then the momentum would be kept, or the energy is released forward, which means then the motion's going to stop. But those are the only options. It's energy in, energy out, motion in between. So as long as you're holding it, all right, you'll gain its momentum.
Photon would not interact, but the problem is the air has slowed it down. It's not at final.
I mean, just kind of a preposterous thing that the little bit of distance of a slit, the amount of slowdown in that little tiny bit of air has something to do with anything. That's just nonsense.
Final velocity, it's not its maximum velocity, and there's that little bit of leeway, and that photon is just looking to burst out into maximum speed. That's
again just rubbish. There's never bursting out at maximum speed. It's either you fly into something, like even an atom. A photon goes into the atom. It's going to go into one side and pressurize an electron, and the idea is that the atom will transmit that around the atom and release the energy eventually. Now maybe it's releasing it from exactly the same point in the atom. Who knows? There's a little time delay between the pressure going in, The atom may be moving a little bit, and then the pressure coming out. And that's the slowdown part, but the energy never slowed down. The force doesn't slow down. The photons don't slow down. They just travel paths, and because they can travel circular paths, it means they can get trapped. Because they can travel back and forth paths, it means they can be trapped. And that's all you're doing, is trapping the momentum. Trapping momentum. That's all the frickin' universe runs on, is trapping momentum.
It's propelled by its own frequency.
So again, it's propelled by its own frequency. How can that mean anything to anybody? I mean, the distance between the cannonballs make the cannonballs move. No. The cannonball was shot out of a frickin' cannon. That's what makes the cannonball move.
It's looking to get out of there at light speed, and it's held back by little bits of air. So what's happening?
Again, this idea that you can hold a photon back is just, in my opinion, a complete non-starter. It's indestructible. Its momentum is indestructible. It never dies. Its momentum never ends. All you can do is trap it. That's it. There's nothing else you can do to photons. They either fly free in a straight line for however long, going the speed of light, or you trap it for a bit. And if you're a single little atom, you'll maybe trap it for a 1/1,000,000th of a second, and then it'll be on its way again. But that's all there is. There's nothing else.
Is that photon is reacting with that air, with the infrared field, with the...
Well, we know the air isn't just air. We know it's atoms. So it's atoms. It's reacting with atoms. And atoms that are mostly transparent. That's what air is made out of, is mostly transparent atoms. Which means they transmit energy consistently. What goes in comes back out. So my argument would be, is what it's doing is it's bouncing in, and then it's bouncing back, and then it's bouncing out. And that's the delay that the atoms cause. But it doesn't change the photon, doesn't ruin its momentum. Certain atoms certainly can do that. They could take ultraviolet photons and give you back infrared photons instead.
The electrostatic field, and it is looking for a get out. And it does. It goes through that, and that little air gap, it acts like a lens. So what I'd like to see is an experiment.
Well, obviously it's not a lens. It's a very particular kind of deflector that deflects at certain angles only. So to say a general word like it's like a lens, well, it's not really like a lens. It's like a lens in the fact that it's diverging light, but it's diverging in a specific way where it only bends at a certain angle depending on the frequency of the light and the width of the slit. So change the width or change the frequency, and you change what angle the photon is deflected at. There's no interference. There's just a changed angle. And the angle is changed by the pressure of the electron.
Experiment where this is done in space at super cold temperatures with different materials for the slit.
I think the only thing you get out of that, this super cold temperatures, again, you have to get rid of the electrons, and electrons aren't easy to vacuum. There's no way to vacuum electrons out of a substance. Realistically, there's no logic that permits you to create any mechanism to pull the vacuum out once you have a certain limited number of atoms so far away from each other. You can't pull on one atom and hope that it's going to pull on the others. There's a certain point where you've pulled all the ones that are at all attached to each other out. And again, the electrons are attached to the protons on the inside of the atom, and they're not part of the atom per se in a bonding way, because it's a weak attraction like a comet. They're stuck in they're attached, but they're not attached. They can be knocked out of that attachment. There's lots of electrons that are going to still be there, but you can't pull them out. There's no string you can pull. You have to pull them out by putting a proton in and having them jump to the proton and then pull them out. You have to fish for them. You have to have bait to pull them out with. So you'd have to use maybe a proton bath and then try to pull the protons out. But again, you can't pull the protons out, because if you have something that has positive charge you put in, you won't be able to pull the positives, are repelling each other, so you won't be able to pull two atoms, won't connect enough to each other so you could pull them back out again.
And using a standard, well, actually I'd like to see two. I'd like to see one done at 650 nanometers and then a complementary experiment done at 405.
Yeah, well, that's already been done, so it's not going to be at all interesting. In my opinion, it's not going to make any difference. There's plenty of people have red lasers and green lasers. These experiments have been done over and over. It just changes, again, the angle. Just changes the angle. No big deal.
5 nanometers, and that would confirm everything that I've been saying here.
No, I don't think it would do any of that.
So I know you guys have waited 3 weeks, and I gave you 3 weeks for the specific purpose. I didn't want you to just run in and say, "Oh, that's crap." I wanted to give you guys time to have a look at, you know.
Yeah, have a look at what? You didn't provide any real evidence here. You didn't even show the pattern. So, what are you? I'm supposed to be impressed by. And you know, again, so you know, replacing rubbish with rubbish isn't an accomplishment. You know, you have to replace it with something that is cognizable. So here you've basically stated that there's a field coming from the surfaces, then you've said there's a field coming off the photons, and then in the end you're basically just reiterating the old theory of somehow photon plus photon equals no photon, that somehow this has something to do with something called interference, that somehow something's interfering with itself. Again, and then you didn't even deal with the fact that this experiment is done with single photons. How does a single photon slow down, have some field thing where it's interacting with some field from the surface that causes it to interfere with itself and go someplace else? You didn't even explain the going someplace else part. You just said they annihilate, or they self-destruct, or whatever the word you used. It's just full of the old jargon.
You know, do your own research. People like Gary out there, DraftScience, he's obviously done a lot of research into it and he's looked into it. I've seen a few of his videos. They're pretty good.
Yeah, well, like I said, nothing against you. I mean, but it's just that this is the quality of the argument. I'm just sitting here saying, okay, you're going to convince me by using the same old jargon words that don't mean anything to me. Okay, these whole field concepts made out of nothing. Fields that don't have a definition, that you're not going to put soldiers in the field, can't mean anything to me. And it means nothing more than bent space means to me. It's just spooky action at a distance. Then again, you're giving photon properties. What property does a photon have besides moving the speed of light and carrying a quanta of momentum? It doesn't have any properties. Whatever it does is going to be dictated by electrons. Electrons control photons. Nothing else does. Everywhere else they go, they just seem to do exactly what they were doing. Nothing changes, so to speak. The only way that changes is because of the way electrons behave when they get hit by a photon. Bound electrons.
But what I'm saying here is people aren't considering the other factors that are in the slit there, and I don't think anybody's considered them. So let's have a look at this double slit thing again, or single slit. And unfortunately I'm in the process of moving house, so I can't set up the experiment here myself, but when I shift to my new location I will have a much bigger area than here, and I will be doing lots of laser based experiments.
Yeah, well, good luck. There's only so much you can glean, as I found. You know, you're basically, they're photons. They're really small. We can't see what's happening between the slits. So I think, you know, the experiment needs to be done, I suppose, is to do the experiment in some way where you can maybe charge the surfaces, do some different things to try to make the surfaces create a different effect that moves the photons. But we've already seen with mediums, like even oil, the best they can do is put a strong magnetic field around oil and then shoot photons through the oil, and they get the oil to change the polarization of the light. but so far there isn't much evidence that you can do much to change the behavior of the bound electrons.
I'm actually into electrical things, electrical experiments, electrical prototyping, very high-speed motors, and I don't really know what gravity is yet. I've got a bit of a lead on it, looking into it. I know
it's photons without frequency. That's how simple it is. It's just a bunch of this little crap moving the speed of light. And when it's not at a frequency, it doesn't knock electrons out of their atoms, but instead gives the electrons momentum in a direction, just like the protons, and that moves things. They absorb the momentum, trap it, and when they hold the momentum, a bias in their momentum, that is, they exchange something going this way for something going that way inside of them. Say right now I have 10 things going this way. Okay, now if I hit a force coming this way, where instead of 100 going this way, it's 101, and there's 100 just coming from the other way. So there's only 100 hitting me this way, and there's 101 hitting me this way. Well, that one extra will mean an exchange, and then my bias now will go one the opposite way. In the sense I've made an exchange. I got rid of something going this way, and now I picked up something going this way. So now my bias has changed. That's all that's happening. So simple. It's just so simple, and all this resistance to the simple answer. All you need is 4 parts. Okay? And really it's only 2 kinds of part, right? Black and red little bits moving the speed of light, black and red fat bits that don't do anything until you hit them with the red or black bits. That's all there is.
No, gravity's not electrical, but wouldn't it be nice if we could build an electrical machine that could manipulate gravity? And I'm not talking like propeller blades. I want to manipulate the gravitational field with electricity. That's my long-term aim. I've got a lot of people.
Yeah, well, it's force on force. So you think you can generate as much force as gravity is generating? I mean, again, I'll make the argument. If you had to move this piece of stainless steel with a heavy battery in it, if you had to move it sideways, you have to put a certain amount of energy into it to move it 10 meters per second, even with no friction. You would have to hit it with a lot of energy, especially if you're using photons or something, a tremendously powerful laser to move that 10 meters per second. So if you want to fight gravity, that's what you're fighting. Gravity's moving one way, all right? That's the way it is. It's got a bias in one direction, a huge bias, and that bias has been created by the Earth blocking a ton of energy that's going the other way. So there's a huge bias built into the Earth on every surface essentially, and that it's based because a bunch of momentum has been captured by the Earth, and that momentum is inside the middle, heating it up. But the point is that from the surface of the Earth, you're not going to, if you want to undo this 10 meters per second, it's the same thing as just imagine, well, how much energy it take to do the opposite. Yeah, it takes a lot of energy. So there's not going to be any magical way to get around it. Again, even all those levitating experiments where you super cool something and then put it on a magnetic field, they're using a strong magnetic field, and they're also using a material that is super light. And so that's like having a wind machine levitate a feather. Not too difficult. Let's see them levitate something heavy with their magnetism. Super cool, a lead brick, and let's see you levitate that.
To help me, and we'll see what we can do. I can usually solve a lot of problems pretty quickly. Sometimes I get stuck, just like everyone else. You leave it, you go back to it later. But anyway, that's my thought on the double slit experiment and what the cause of the defection is. It doesn't...
Way overstated. I mean, you promised this resolution. They spent 200 years thinking about this and had no resolution. You have the solution. This wasn't much of a solution.
Doesn't prove it's a wave at all. it would prove it has wave-like features in that particular experiment, but every other experiment I've seen, a photon acts as a true particle. And
right, so you haven't resolved this paradox. You're saying it has wave-like features. I'm saying it doesn't have wave-like features. All right? They're not. What it looks like isn't what it is like. It doesn't have any real features that have anything to do with anything called a wave. It has to do with things being deflected at an angle. That's all the math says, is an angle, sine theta. That's what's in the math, just an angle. All this crap made up about a wave is crap. It's not have anything to do with what we know is causing the effect, which is the distance of the slit, and in the case of the double slit, the distance of the impediment, which is an important distinction. And the real point is that that distinction is really just the distance between the surfaces. So whether I count the slit and do this surface, that's a distance. And if I have an open slit, this distance and this distance would be the same. So we're really just talking about the distance between the surfaces, regardless of whether they're hollow or not. It's the surfaces that are causing the effect.
An example of that is a photon. Well, if a photon is a wave, how does a...
So why do you even bother? I mean, you've just pointed out, like I said, the fundamental to your theory was some idea of interference. How do you have interference if they're not waving into the interference?
The photon, as a wave, travel across 100 billion light years. Or, and they do. We're detecting photons here billions of years old, and they haven't lost any energy coming all the way from galaxies far, far away from a long, long time ago, like Star Wars, and we're getting these photons, and they haven't lost any energy. They're still the same frequency. They've still got the same initial energy that they left.
Yeah, well, the frequency's a little bit, they have maybe lost some frequency, but that's because they interacted with something that had opposite momentum. But yes, their momentum is intact, but their frequency may be reduced. So they've been lengthened as a ray. You can change the length of the ray without changing the energy of the ray.
Left with, and that's only because they are a massless particle. If that was a wave, it'd be the inverse square law, and you'd be lucky to receive it 1 billion kilometres away, let alone 1 billion light years. So that's my take on...
Well, obviously by that definition of wave, a spreading wave, but that's not what their theory is. It's some wave that doesn't spread and doesn't require energy to manifest or some kind of crap like that. Totally incomprehensible. But again, you haven't made it comprehensible either.
On the view of what a photon is, I'll treat it as a particle of energy. I'll treat it that it has no mass. It does carry momentum. I'll agree with DraftScience Gary there. We do agree on a couple of things here and there, maybe not a lot, but we do agree on a few things.
Yeah, I know, but barely, right. Well, I mean, agreeing that it has momentum is like agreeing that water's wet. I just don't, how could anybody avoid the fact that the photon carries momentum? It'd be impossible to say it doesn't carry momentum.
So I agree that a photon does carry force with it, and you can see that with any radio.
Well, again, it doesn't carry a force, it is the force. So another way of saying it is, it's just, again, we have this notion that somehow photons are a carrier. No, they are the force. They're not carrying the force. They're using like virtual photons to explain magnetism, even though of course they don't explain magnetism, they just invent a carrier. So they have this virtual photon that carries the effect somehow. No, the photon is the effect, it's the force.
Diameter or solar, those solar sails in space. They get pushed along by photons. So there's one guy who had an experiment with a laser.
Yeah, well, none of that crap has ever been built, so until they build one of those, it's kind of just rubbish talk.
Powering a silver disc, and he was shooting it up a pole with this laser that's on YouTube. But that also could be the photons ionising the metal, and he's actually getting ion propulsion. Yeah, that's debatable. So that's my thoughts on a photon.
Yeah, I know, but even to get that, you have to put energy in to get ions out, so clearly the momentum is being exchanged. in the sense that you're putting something in and something else is coming out the opposite way, and you have to put the in to get the out.
Being particle and my thoughts on the double slit experiment. If you like, leave us a like. If you disagree, leave us a dislike, and you'll be seeing a lot more from me on.
Alright, so enough. So anyway, like I said, likable guy, but you know, all these dissidents are sort of likable people in one way or another, but it's all this, like I said, I can't make anything out of what they're arguing, and apparently they can't see the distinctions between, you know, they're looking at my theory and saying somehow they can't get it. Apparently, I can't see how they can't get it. It works so well and answers all the questions, and they certainly don't point out any experiments with I can't explain how my theory works in terms of what you get as a consequence. You know, now clearly I can't give you perfect detail regarding how electrons are jiggled in some perfect detail, but the idea of understanding that the photon is a manifestation of the force trapped between electrons, and that when electrons do make exchanges, that is, when they do travel, they do, as a fact, appear to lose momentum, and they're losing it in the form of creating photons, would be the logical, the thing to recognize. If they lose the momentum in a circumstance where they have tension. If they're not under tension, then they're going to lose the momentum at very long wavelengths. So it might be a radio wave or something, I mean a radio ray. So you're not going to see it as a photon, because they'll be able to lose their energy over much greater distances. But if they're in tension, if they're attracted to a proton and they're repelled by other electrons, then when they lose their momentum, they're going to do it quickly, and that's the frequency of light. More pressure, the higher the frequency. Less pressure, the lower the frequency. Kind of obvious, in my opinion. Obvious. It's obvious. Yeah. X-rays, ping pong balls trapped between two electrons that are close. You know, light, visible light, microwaves, radio waves. Well, radio waves, I would argue, aren't really trapped in the atoms, frankly. I mean, obviously this meter-long stuff. So they're produced by a slightly different function, which is more electrical in nature, you know, charging the atoms and then having all the atoms vibrated at the same time. So it's a little bit different. So anyway, till the next time. I mean, how these different things are created, these are all important distinctions. There's lots of details that are important. But as a general theory, there's no ambiguity in what I'm saying. I'm saying there's two force bits and there's two matter bits. That's all there are. Everything else is a manifestation of those things, is a grouping or a collection. Everything else is made out of those elemental bits. Positive charge and negative charge, matter, and positive and negative force. And that's it. Everything is made out of that. Alright, that's enough. So, till the next time and such.